All right, I hope you're excited. I really like this stuff. 8.3.5 is really interesting problems for me to solve, so we'll see if they're interesting for you. But otherwise, even if they're not interesting, you can learn how to do it anyway. So we're going to first, so in the last video, we talked about a specific type, F inverse of f of x. Now, F inverse of g of x. What happens if it's a different function? Before, they could sometimes cancel out. Here, they're never canceling out, all right? And there are multiple ways of doing this. There are two methods of doing this. One of them uses cofunctions. I'm not even going to bother introducing the second way for these ones. I'm just going to do the direct method, that red method from the previous video, okay? Evaluate. Part A, inverse sine of the cosine of 13 pi over 6. All right, we're just going to evaluate cosine and then take the inverse sine of that. All right, so we go over here, say 13 pi over 6. I've got no idea what that is. Let's look at it. 13 pi over 6. Well, that's a little bit more than 2 pi, right? 2 pi would be 12 pi over 6 plus another pi over 6. Okay, so we just go all 2 pi and then another pi over 6. Our reference angle is pi over 6. So it's the inverse sine of pi over 6. What angle in the range of inverse sine is going to give us pi over 6? Remember the restricted domain of sine, so the range of inverse sine, the range of arc sine is negative pi over 2 to pi over 2. So hold on, I'm jumping out of myself, right? This is inverse sine. The cosine of pi over 6 is going to be root 3 over 2. So what angle in this interval has the sign be positive root 3 over 2? We think it might be pi over 3. Pi over 3 is in the range. Pi over 3 would give a positive angle. I hit my glasses again. So it should be pi over 3. And again, you can check your answer with a calculator using the same method as 8.3.4. I don't know why I circled 8.3.5. That's different. All right. That's how you can do these ones. So like in part B, if we did another one, arc cosine of the sine of a negative 11 pi over 4. And again, we're looking at, okay, what's the range of arc cosine? Range of arc cosine or inverse cosine is 0 to pi. We're going to use that. So let's go off to the side. Let's look at negative pi over 4. Sorry, negative 11 pi over 4. That's negative 8 pi over 4 minus another 3 pi over 4. And again, just like before that, right? Just like before, this is negative 2 pi. Wait, did I do the same mistake that I've done? Oh, this is interesting. No, I didn't. I did draw a positive angle. I almost made the exact same mistake that I made in like an earlier video. That's bizarre. But I did correctly go up. So this is going to be going down 2 pi and then another 3 pi over 4. We're going down 2 pi and then another 3 pi over 4, which is right here, a reference angle, pi over 4 in the third quadrant. All right. That should be negative 11 pi over 4. And let's say, hypothetically, you were nervous about making a mistake. You could check. Check your answer by going over here and saying, what's negative 11 pi over 4 in degrees? Multiply by 180, divide by pi. It's negative 490 degrees. Negative 495 degrees. negative 495 degrees. That's all right. So it is negative 135 degrees is the coterminal angle. Negative 135 degrees is this angle. If you were hypothetically nervous about making the same mistake as in an earlier math problem, you could check that. That's how you would do it. Okay. All right. So what is the sine of that angle? Sine of that angle, well, it's pi over 4. So that's going to be 1 over root 2. Use those special triangles. But then remember, all squids train camels, always save the cats. Only tangent's positive here. So in the third quadrant, sine is negative. So we need to now ask ourselves, all right, cosine of what angle gives us 1 over root 2? And I immediately think pi over 4. Cosine of pi over 4 gives 1 over root 2, but it needs to be negative. How do we get negative 1 over root 2 that's in this interval for cosine? Well, cosine is negative on this restricted domain in the second quadrant. So we need something with the second quadrant with this reference angle. Second quadrant with reference angle pi over 4. That's going to be this blue angle right here, 3 pi over 4. And again, these problems are pretty complicated. The quiz is going to have pretty complicated problems. Check your answers. Inverse cosine of the sine of negative 11 pi divided by 4. Let's make sure I typed it incorrectly. Inverse cosine of sine of negative 11 pi over 4 should equal 3 pi over 4. Good. They equal. All right. Check your answers. Get good quiz points. All right. And let's do one more form. F of g inverse of x. This is usually the weirdest one. All right. But these are the fun ones that you get to visualize a little bit. Let's do that example 6. We'll do 3 of these. Evaluate exactly. Part A is going to be, what is the sine of the inverse cosine of the ratio 4/5? So the real hint for these ones is, remember that inverse cosine takes in a ratio and outputs some angle. And specifically, inverse cosine will output some angle in this restricted range. It's the range of inverse cosine. It's the restricted domain of regular cosine. So this is what we kind of visualize here. Look at something in the second quadrant or the first quadrant. It's going to be in the first quadrant because it's positive. All right, we know theta is giving a positive ratio. Positive ratio. So quadrant 1 is where theta is. And the adjacent divided by the hypotenuse has this ratio. And again, we don't know the size of this triangle. This triangle could be way bigger, right? It could be 8 over 10. We don't know the size of this triangle, but we do know the ratio is this. So we're only looking at trig functions. We can just make a dummy triangle. I don't know how big the triangle is, but we can use a dummy triangle. And is a positive ratio. So theta is just some angle in the first quadrant. Now, we need to know what the sine of that angle is. It's the same theta. I'm going to write the theta in red still. It's the same theta. What's the sine of this theta? I don't know. It's opposite over hypotenuse. We don't know the opposite. Let's find it out. Say the opposite is some y. It's going to be 3. It's a special triangle. All right. So what is the sine of theta? Sine of theta is opposite over hypotenuse. And I went through that really quickly. I was really excited. I'm going to go slower in part B. Okay, I like these problems. Let's try to really illustrate the logic and the thought process in the next video. Nope. Well, yeah, in the next video too, but also in the next problem. Okay, part B, let's look at the sine of inverse tangent of 2. So we're going to use the same logic. All inverse trig functions take in ratios and spit out angles. And for good measure, let's say -2. Okay. So remember the restricted domain of tangent, or the range of arctangent. Right? Range of arctan is -pi/2 to pi/2. You can use that table from that very first video, 8.3.1. Use that table to get this information. That's the range. We need something in that range, or it's negative, right? It needs a negative ratio. All squids train camels. What's something in this range that's negative? Well, it has to be fourth quadrant. Right? The reason quadrant 4, because it has to be in this range and it has to be negative. Theta is in this range and tangent of theta is negative. That's how we chose quadrant 4. So you have some angle in quadrant 4. I don't know what it is, but this is some angle in quadrant 4 whose tangent is -2. Right? Where am I getting that? If theta equals the inverse tangent of -2, then tangent of theta equals -2. That's that relationship from 8.3.1, the first video of this section. So tangent of theta means opposite over adjacent. That ratio is equal to -2. If I want, I can write -2 like this, right? Just to show that it is a ratio. -2 is the same as -2 divided by 1, so let's do that. So the opposite over the adjacent is -2 over 1. Right? And we can think about this as a -2 if we think about this as the y-coordinate, right? We're going down. It's going to have a negative y-coordinate. And what we want to do is we want to find the sine of this angle. Sine is going to be opposite over hypotenuse. We just need the hypotenuse. So we could call this hypotenuse C, X. You could call it whatever you want. If we call it C, then 1 squared plus -2 squared. We should technically use positive. It doesn't really matter. Equals C squared. That's 1 plus 4 equals C squared. C is going to be the square root of 5. So sine is opposite over hypotenuse. It's going to be -2 over the square root of 5. And let's say hypothetically you were nervous. You could always check your answer. I'm pretty confident about this one. So let's look at this. This is, oh my word, I just did something. The sine of arctangent or inverse tangent of -2. Is that indeed our answer? What was our answer? -2 over root 5. Hey, they match perfectly. Great. That's the exact answer, and that's how you use your calculator to check it. The book, right? The book would rationalize the denominator. It would have negative 2 root 5 over positive 5, but they're the same answer. All right. Let's end with one really special problem. Part C. Find the cosine of the inverse sine of x over 3. What? And specifically, x is going to be between negative 3 and positive 3. Don't freak out. This is exactly the same as the previous problem. Well, not exactly. It's very close to the same as the previous problem. Inverse sine takes in a ratio and spits out an angle. All this is asking is what is the cosine of that angle? Okay. What's the range of inverse sine? The range of inverse sine, negative pi over 2 to positive pi over 2. Okay. So x is either positive or negative. We don't know, right? X could either be positive or negative. We don't know whether the ratio is positive or negative, which means we don't know whether we're in the first or the fourth quadrant. But it's actually going to turn out not to matter. Okay? So let's just draw a picture of one in the first quadrant. Let's say this is theta. Well, the sine, again, if inverse sine of x over 3 is equal to theta, then the sine of theta is x over 3. I don't know the size of this triangle, but I know the ratios look like this. Again, maybe this triangle is twice as big, maybe it's 2x and 6, but the ratios are what we care about for trig, so we can draw a little dummy triangle. And I want to know the cosine of that angle. So I need to know what this is over here. We can call this A. We can call this whatever we want. Well, I know a squared plus b squared, which is x squared, equals 3 squared. And we need to solve for a. So subtract x squared. That'll just give us 9 minus x squared and take the square root. So it's either positive or negative. We actually know it's positive here because of the range of sine. We're either in the first quadrant or the fourth quadrant. So this is going to be a positive x coordinate. So a is equal to the square root of 9 minus x squared. So the cosine is going to be adjacent divided by hypotenuse. That's the adjacent. That's the hypotenuse. And there we go. That is the cosine of theta. And here we go. So when I said, why does it not matter whether it's in quadrant 1 or quadrant 4? Here's why. Because we're looking at cosine. Okay? I don't care whether we're in quadrant 1 or quadrant 4 for cosine. It's going to be positive anyway. So that's why it didn't matter which one it actually was. And that's how you do these sorts of problems. I think there's a couple of those. Let me know if you have any questions and enjoy this gift of mathematics that I'm giving you. Well, it's not really a gift for most of you because most of you are paying for this class. But if you're just watching this on YouTube for fun, then yeah, it's a gift, a free gift. Have a good one.